Hi, welcome to PR Tech Talk. What MCU should you select in your next project? Well, it depends on many parameters. If we in this video limit us to what STM32 microcontroller to use, it still depends. But I would like to make an attempt to give you my thoughts on how and what family to choose between, and what to try to avoid. Further, when a suitable family is selected, there are still many options. But here ST has some tools for us, to guide us and to find a possible candidate. We will also use the STM32 CubeMX to narrow down the candidates. After that, I will also take a look at one general purpose microcontroller and have a little look at the clock configuration tab in the STM32 CubeMX. Here we see microcontrollers from ST, the various families. The one in darker blue are the selected or the preferred versions, and they are in the gray are still available and still with 10 years longevity, but I would try to avoid those. So if we take a look at the left part there, we have the STM32 C0. That is their entry microcontroller, their lowest cost, the lowest performance, and actually aimed to be a replacement for the 8-bit family. So if you would like the smallest and lightweight microcontroller, that is the family to go with, this STM32 C0 family. And if that performance is not enough and you would like to have a bit more performance, then I would go up with the STM32G0 family. It's still Cortex-M0 Plus, but it has a slightly higher clock frequency and a little bit more of the peripherals. If you would like to have a little bit more performance, then I would change up to the STM32G4 family, which is then the Cortex-M4 family, and that goes up to 170 MHz. If you would like to have a high performance, then I would suggest that you look at the STM32H5. And here we changed the microcontroller for M4 to the newer Cortex-M33. And that one runs also up to 250 MHz. And if you would like to have even more power than the H5, there is the H7, and that could be actually a dual-core microcontroller based on both Cortex-M7 and also Cortex-M4, both in the same device or the same package. Then there is one further up there, and this is their MPU, so it's not a microcontroller any longer. So this is a device that you can run a Linux on. So it's called STM32MP1. But then if you would like to have a very low power device, then I would suggest that you look at the STM32U5. That is their lowest power consumption microcontroller. But still there are some STM32L4 that you could take a look on if you don't find a matching part number for the U5 so far. In the very bottom you have the wireless microcontrollers, so that is new for ST, that they are now focusing more and more on also wireless. So here you have STM32WL, which is a sub-gigahertz wireless microcontroller, so it's an STM32 M4 with the Cortex-M0 for the wireless part. Then you have the STM32WB, and that is a bit older part. It's a dual-core part, so you have a Cortex-M4 for your user application, and you have a 32 MHz Cortex-M0 that runs the radio. Then you have the newer version, that is the STM32WBA. So this is a single-core MCU, and it runs on Cortex-M33 altogether. I would try to very much avoid STM32F1 or F2, even F4 and F7. I would really strongly advise you to look away from those, because there are better candidates to choose from that are easier to get hold of. So then when you have selected which family you would like to use or run with, you might as well get a development boards. And the one that you see on the picture here or in the camera is what the form factor is called a Nucleo. And Nucleo is as base board as you can get it. There is normally one LED and one user button, but you still have all the I/O pins for all functions available for you. So this part is the debugger, and it could be break off because there are break off pins here. This is actually one of the devices that is preferred, and it's C031 C6, and the board is the Nucleo 031 C6. And here we have all the Arduino headers, and these headers are called Morpheus because all the Arduino headers don't, you can't use all the pins on the device on the Arduino header, so ST have their Morpheo bus outside here. So this is the C31. And if you go up a bit in the power, I said that the G4, this is very similar. If we take comparison, they look more or less the same. So you see the form factor. If you use one, you can see very easily that they are very similar. In this one, you don't have the breakout board pin here, so you can't break that board. But still, it's the same device, same form factor, the Nucleo. Another Nucleo board can look like this. This is the H5, the Cortex M33, which I also said was one of the preferred devices. Here you have some more features, like you have an Ethernet jack and a USB port as well, since that is available in this bigger device. So these are the Nucleos. But then we have more purpose-built or application. So this is a discovery board. So in this case you have the microcontroller up here, and it's a wireless microcontroller, so it's the STM32 WB55. And on this one that I have not made a video on yet, so this is the STM32 U5 with a very nice round display on it. So this will be coming in a video in the future. And on the H7, it's a huge board and a huge display. So this is also a discovery board. I can't even get it to fit in the screen here. So these are with all the bells and whistles, but still there is an Arduino header on it. And here we have another STM32 U5 board. If I can get it to like so. And so there we have the microcontroller, and up here we have actually the STM32 WB55 as we had in the last one. And this is one debugger for the microcontroller up here. Now I think that I should look into some of the STM32 CubeMX features that we can use for selecting which device we would like to work on. And I, in my case, would like to work on the G4 family. So I normally do like this. I go new STM32 project and the CubeMX will start. So here we have the STM32 CubeMX started. And there you have 4 different tabs. You have MCU, MPU selector, board selector, example selector, and cross selector. If we take the MPU and MCU selector, and we have a rough idea on what we would like to do, and in my case, I would like to work with the G4 family. It suits me in the performance and so what. And if we just take a look in these numbers, in this current release, it says that there are 3,775 different microcontrollers from ST, so there is some to choose from. So if we go with series in my family, in my case, so I would go with the G4. Now immediately we see that we only have 261 decisions to make, and that is good. So if we go then further on, we can see if we know already which family we would like to have, all the rest is grayed out. I don't, so I don't use anything here, but I would like to have some memory in it. I would actually like to have very much memory in it, so I would like to have 512K, let's say that. So I would like to have the maximum memory size. And I would also like to have a package. I know that I would like to have a 64-pin device. So I can narrow down to 64-pin. Now we're down to 20 devices. Okay, so we can then take a look here. I know which one device I would like to work with because I have the board on my hand, but we can make more selections here on analog. If we would like to have analog, if I would like to have CAN, for instance, I say that I would like to have at least 2, or I absolutely must have 3 CAN. Then there is 10 items. But then I saw also my board got lost. So you can make selections here from how many SPIs, how many I2Cs, how many UARTs you would like to have. And then the number of devices get narrowed down. So this one is the one that I would like to work with. And the difference between those two, or this one or the later one here, is on tape and reel. So if I click on this one, I get all of the information on it. I get the block diagram, a document resources, CAD utilities, data sheets, and etc. You also get the price tag on the 10K volume, and you also get to know which board that you should be using. And also, then if we click on this one, we see a roughly estimate on the board. And if we take a quick look, it's this device that I have here on the board. So what I do now, I go with next. And we give it a project name. In this case, I said no to this one because I would like to work on the clock tree. So here we see the device in normal, and if we go under System Core, under RCC, here we have the clocks disabled. And if we then just remain with the clock disabled here and go under Clock tab, we see here that this is the clock configuration. It's there are many clocks that you need to take into considerations when you make a design. This part here is in my eyes the most crucial one. It's the heart in everything, and many problems is related to this device here. So this one is HSI. It stands for high internal clock, high speed internal clock, and there is HSE, that's high speed external clock. And this one is blue, that one is gray, so that one is actually the selected one. So if we take the flow diagram here and see, so we have 16 megahertz high HSI RC internal clock, because all this is internal. Left of this board, that is external of the MCU. So this is in an internal clock for 16 megahertz. So we take this line and feed it up here to this multiplexer, and we also source it into this multiplexer here. Then we take this and we divide it by 4 and multiply it by 85 and divide it by 2. And then we get the system clock on 170 megahertz. That is the maximum that this device can handle. If I would like to have a lower clock frequency, I can actually just write like here, so I say 64 megahertz, and it changes everything for me. It finds a solution, so you don't need to calculate these multipliers and dividers by yourself. But if I would like to have an external clock, how to do then? You can't click here. You can't use this one. It's not available. Because you need to enable it first in the high speed here. So here we see that I would like to have a crystal resonator. So if we now go here, now you see that we have connected the external. And here you see it's between 4 and 48 megahertz that is available for us. And on the board there is a 24 megahertz crystal. So now we have selected the high clock source external, but this one is still selected. So if I would like to use this one, I need to do it like that. And then also use the PLL clock. And now I can also make my request here if I would like to have 64 megahertz. For instance, you see all the clocks are nicely 64 megahertz. And now we see we use the high speed external, and that one goes into the PLM. Divide by 3, multiply by 16, divide by 2, and then you go up here and use source 64 megahertz, and you have a divider on 1 and 64 megahertz again. So all these calculations, it's not needed for you to do. It's done by this tool. Then there is a small block here, enable CSS. CSS stands for Clock Security Systems. So if we enable this one, so now it says CSS is enabled. If we enable this one and you run from an external clock, everything is fine. But if there is any problems with this external clock, if it's broken or something and you don't get any clock any longer, then this one detect it and switch over to the internal clock. And on the same time, it also gives you an NMI to your system that there is something wrong in your system. And if we see now that we have 64 megahertz and then it switches to the internal clock, you see that all clocks are now then 16 megahertz instead, because it's running from this. It doesn't go through this PLM any longer. It goes from the high speed internal. So it will go slower, and it will give you an NMI to handle your error. So it won't fail altogether, it will halt into your goal. Up here you have another tree, and that is the low frequency for RTC. And now you see we have the 32 kilohertz internal, low speed internal RC, and that one is used. But it doesn't source anything, it's grayed out, so it don't use any 32 kilohertz at all. So if we go here and we say, okay, but we put a crystal on it then. Okay, so we put a crystal on it, but still it doesn't source anything, because it goes to the internal watchdog and it goes to the RTC, and we haven't enabled any one of those. So that is the reason they are not there. So if we would like to have this available for us, we need to actually enable the RTC. So we can go down to timers. I think it's, oh no, it's very narrow. I think it's on the timer. There we have RTC. So if we enable RTC, now you see that there is a 32 kilohertz there. And we can do the same thing here with the enabled CSS if we use an external crystal, because that one can also fail. and then it will switch over to this one. So you can enable that one as well. This is still not activated, so the reason for it is that we have not enabled it. So we go to internal watchdog and we activate that one. So now we have the 32 kilohertz to the internal watchdog. And we have now selected the external, and you can then also make use of the internal if you want. Then you can't use the clock security system because you can't monitor the external crystal if that one is not in use. So all these things we can do here on this panel, but you can also do that in software in your code. So if we now go back, and I don't want to have the, well, there is one thing more that I would like to look at. We have a master clock output as well. If we enable that one, something happens here. This pin is an output actually, and it outputs a clock. And you can select from here which clock you would like to output. So if you would like to have the system clock up here, that is 16 megahertz, and if we put that one there, we get 16 megahertz. And if I only want half of that, I can put a divider on it and I get out 8 megahertz output. So that is something that you can use mainly to many applications, but I normally do it to verify that I have got my system clock correctly in a debug phase. But normally that is turned off to save pins. And we would like to also turn off the low there. Oh, so you have that resolve clock issues there. If there is any problems with it, then you can hit that one. And RTC and internal watchdog, we need to take away those as well, because I'm not going to use them. So now I still have my 24 megahertz external, and I have my high-speed external, and I run it on PLL and 64 megahertz. That is what I would like in this application. And I have an LD2, which is my LED that I would like to have to blink, and we can just continue the program from here. We generate the code. And we go down to the while one loop. And one of my subscribers said that he couldn't get a control space to work as an autocomplete when he was running Windows 11, and I'm running Windows 11 now, and it worked fine in my installation at least, so it should be working. So here I see I would like to have the toggle pin, and if I was correct, was it called LD? Yes, LD GPIO port, and the GPIO pin, and just put LD and then control space, the pin, and end it with a semicolon, and 250. This is not a C programming course. It's how to use the tools. Okay, we debug it or build the project, and this big project gets 0 errors, 0 warnings, and we hit the debug icon. and it automatically goes over to this perspective that is the debug perspective. So it's downloaded successfully, and it stopped on HAL init. And if we now change back to the board that we have here, we see that there is no LED blinking more than this one, and that one is indicating for ST-Link communication, and the green LED there is a power LED. So there should be a LED somewhere here when we blink it. So I go back to the project and I hit the run button, and we change back to the there it is. LED blinking there. Hope that you now got a bit an update on which STM32 microcontroller family to choose in your next design. If you have any comments, please use the comment field below. And if you liked the video, please give it a thumbs up. And if you're still not a subscriber, please consider to do so. Until next time, stay safe.